All right, today we are starting a new chapter, chapter 8, which is about complex numbers. So we're going to begin with section 8.1, which is about pure imaginary numbers. So first, let's just get a definition of what an imaginary number is. An imaginary number is I. Okay, so the definition of that is the square root of -1. So you cannot take the square root of -1, it's an imaginary number. However, if you do I squared, you would get -1 by itself, since the square root of -1 times the square root of -1 would just be -1. So again, an imaginary number, I, is the square root of -1, such that if you do I squared, then you would get -1. So what we can do is that we can take powers of I. So to remind you, remember I is the square root of -1. So I squared is the same as saying I times I, which is the square root of -1 times the square root of -1. And we learned in the last chapter is if the indexes are the same and you're multiplying by them, then they will cancel, leaving you what's inside the radicand, which is -1. Now, if you were to have I cubed is the same as saying I times I squared. Well, remember, just right above it, we said that I squared was the same as -1. So I times I squared becomes I times -1. We replace the I squared with -1. So we have I times -1, which is -I. Then we have I to the 4th. So I to the 4th is the same as saying I squared times I squared. -1 times -1 becomes +1. So do yourself a favor and memorize the first 4 powers of I. So memorize that I by itself is the square root of -1. Memorize that I squared is -1. I cubed is -I. And I fourth is +1. If you will memorize that, it's going to help you for this chapter. Let's go ahead and look at more powers of I. So I to the 5th is I to the 4th times I, so that becomes I, because remember, I to the 4th is 1, and then I by itself is I, so 1 times I is I. And then I to the 6th becomes -1 because that's I to the 4th times I to the 2nd. I to the 4th is 1 and I to the 2nd is -1, so you get -1. I to the 7th is -I and I to the 8th is 1. You should see that, hey, this is the same pattern as I to the 1st, I to the 2nd, I to the 3rd, and I to the 4th. And that pattern actually continues for all of the patterns of I. It will keep going. So I to the 9th would be I to the 10th would be -1, I to the 11th would be -I, and I to the 12th would be 1. So it just follows that same pattern. So here are some more powers, okay? So the reason, because of this, because it follows that pattern, we can actually get the power of I for any power. It can be as high, you can get a really high power just by recognizing that if it is a multiple of 4, then it's going to be 1. And if it's a multiple of 4 and with the remainder of 1, it will be I. If it's a multiple of 4 with the remainder of 2, it's going to be -1. And if the power is a multiple of 4 with the remainder of 3, it's going to be -I. So it follows that pattern. Okay, so again, the pattern is if the power is a multiple of 4, then it's going to be 1. If it's the multiple of 4 plus the remainder of 1, it's going to be I. Multiple of 4 plus 2 would be -1. And a remainder of 4 with 3 as a remainder is going to be -I. So let's restate that that rule again as steps. So here are the steps on how to find powers of I. So the first thing you'll do is divide the exponent by 4. And the remainder is either going to be 0, 1, 2, or 3. So based on the remainder, it's going to get your answer. Okay? So if your remainder is 0, then it's going to be 1. If your remainder is 1, it's going to be I. If your remainder is 2, it's going to be negative 1. If your remainder is 3, it's going to be negative I. So to simplify power of I, divide by 4 and leave the remainder. So let's look at I to the 27th. Okay, so I to the 27th is I to the 4th to the 6th times I to the 3rd. Okay, so 27 divided by 4 has a remainder, okay, because 4 does not go into 27 evenly, right? So 4 only goes into 27 6 times, right? So that's how they get I to the 4th to the 6th, because 4 goes into 27 6 times. So 4 times 6 is 24, with the remainder of 3. So this is where they get I to the 3rd, because this represents the 3 remainder. Okay, so remember, I to the 4th is just 1, right? So you have 1 to the 6th power, which is 1, and then you have I to the 3rd power, which you memorize to be negative 1. So you have 1 times negative 1, which is negative I. Let's try a bigger number. If you have I to the 489th power, well, 4 goes into 489 122 times. So that's why we have I to the 4th to the 122. It has a remainder of 1, so that's where you have times I, because this is I to the 1st power, because there was a remainder of 1 when we divided 4 into 489. So I to the 4th is 1, and 1 to the 122nd power is still 1. And then we have times I, so 1 times I is equal to I. So you try this one. Do I to the 34th power and see if you can see what it simplifies to. All right, you should have gotten negative 1, because if you look at 34, 4 goes into 34 8 times, because 4 times 8 is 32, which leaves you a remainder of 2. And I to the 2nd power is negative 1. So that's why this simplifies to negative 1. Let's try another one. I to the 135th power. All right. So if you did this correctly, you should have gotten option 3. Okay, so 135 divided by 4, it does not divide evenly. It looks like that 4 will go into 135 33 times with a remainder of 3. Okay, and because there's a remainder of 3, we can do I to the 3rd power, and I to the 3rd power is negative I. The reason that we want to be able to simplify imaginary numbers is because it helps us simplify radicals that have negatives in them. For example, if we have the square root of negative 9a, before now, we've always said, oh, you have a negative in your radical, something went wrong, do the problem again, because you can't have a negative, you can't take the square root of a negative number. Well, starting from now on, that's not the case anymore. We have introduced imaginary numbers. So now it's going to be very common for you to see a negative in the radical. So in this case, we have negative 9a. So one of the properties that we learned is that if you have a product in the radical, that we can actually split it up into factors. So negative 9 is the same as saying negative 1 times 3 squared times a. Okay, so now this can be split up, and the square root of negative 1 is I, the square root of 3 squared is 3, and the square root of a does not simplify, so that's why we are left with the square root of a. So So we end up with 3i square root of a. Okay, so let's simplify. So these are the steps on simplifying radicals with negatives. Step 1, you're going to change the square root of -1 to I. That's always going to be step 1. Step 2, simplify the rest of the radical as usual. So that was pretty simple. There were only 2 steps, but just a quick word about your notation. When you're writing your answers, order is very important to keep things clear. So when you're writing your answer, make sure that you write any coefficients first. After you write your coefficients, you can write your variables, and after your variables, you can write I, and then after you write I, you can write any radicals that you may have. So order is important. It should be written in this order. Okay, so let's look at the square root of -25. So the square root of -25 is the same as saying the square root of -1 times 5 squared. So the first thing we do is we rewrite the square root of -1 as I, and then once we've done that, we take the square root of 5 squared, which is 5. So it simplifies to 5i. Notice how I wrote my coefficient first and then my imaginary number. Let's do the square root of -81 x squared y. So the square root of -81, I'm going to take the square root of -1 out, and that will give me my I. Okay, 81 becomes 9 squared, and we have x squared times y. So again, this square root of -1 becomes my I. The square root of 9 squared is 9. The square root of x squared is x. And then the square root of y does not simplify, leaving me the square root of y. So look at the order of this. Notice how I wrote my coefficient first, then my variable, then my imaginary number, and then my radical. So that's why I wrote it in this specific order. I wouldn't put my 9 afterwards or put my x afterwards. Make sure you do coefficient, variable, imaginary number, and then radical. All right, let's do the square root of -28 x to the 4th y cubed z. So it looks like we're doing the square root, so that means we're looking for squares in here, right? So first of all, -28 breaks into -1 times 2 squared times 7. And then x to the 4th can be rewritten as x squared, and y cubed can be rewritten as y squared y, and then z is going to still say z. Okay, so from here, the square root of -1 becomes I. The square root of 2 squared becomes 2. 7 to the first power cannot be simplified, so that will stay in. X to the 4th, remember, broke down to x squared and x squared, which means that 2 x's came out, giving me an x squared on the outside. Y cubed broke down to y squared and y, so I had a y come out and then a y stay inside. And then the z also stayed inside. Okay, so I wrote coefficient, variable with a higher power, next degree variable, then my imaginary number, and then my radical. All right, your turn. Try the square root of -27a. Okay, you should have gotten number 3, which was 3i square root of 3a. And the reason why is because -27 will break down into -1 times 3 times 3 squared. So the -1 became the I, the 3 squared became the 3 here, and then the 3 stayed inside and the a stays inside. Okay, let's try this one. All right, you should have gotten option 1, which was 2ai square root of 30ab. So -120 would break down to -1, and then if you break down 120, that breaks, you can do a factor tree if it helps you. And if you do a factor tree, you'll notice that that became 2 squared times 3 times 5. So the 2 squared breaks out, right? And so then you have 2, and then the -1 becomes your I. the 3 and the 5 stay inside, and then you have another 2 on the inside as well. So 15 times 2 is 30. So that's how you get the 30 here. And then a cubed becomes a squared times a, which means an a comes out and an a stays inside. And then, of course, the b will stay inside as well. So another a way that we can use this to help us solve equations is if we get something like this, x squared minus 16 equals 0. If we were to solve for x, we would add 16 to both sides. And then we have x squared equals 16. So we would square root both sides, but when we square root, because we're taking the square root of x squared, the answer could be positive 4, but it could also be negative 4. Because if you think about it, 4 squared is 16, but negative 4 squared is also 16. So we have to indicate that it's plus or minus 4. Now, if we have x squared plus 16 equals 0, we would have to subtract 16 from both sides. And this is where you might be thinking, oh, I'm making a mistake. How can I take the square root of negative 16? Well, now that we know how to deal with imaginary numbers, we know, oh, negative 16 is the same as saying negative 1 times 16. And the square root of negative 1 is I, and the square root of 16 is plus or minus 4. So our final answer becomes plus or minus 4i. Let's do another one like that. Let's do x squared plus 18 equals 0. So we'll start with subtracting 18, and then we have x squared equals negative 18. So we have to break negative 18 down. So 18 will break into 2 times 3 squared, which means we have a negative square root of negative 1, which will become I. And then we also have 2 times 3 squared. So when we take the square root of negative 1 became the I, the 2 stayed inside, and the square root of 3 squared became 3. And because we took the square root of both sides to solve for x, we'll do plus or minus. All right, try this one. So remember, first step is subtract 32 from both sides, and then you want to go ahead and break down 32 as if you were simplifying a radical. Okay, you should have gotten option 2, plus or minus 4i square root of 2. So because 32 breaks down into 2 times 4 squared, the 2 will remain inside and the 4 will come outside. And then because it was negative 32, the square root of negative 1 becomes the I. And because we took the square root of both sides when we were trying to solve for x, that's how we get the plus or minus. Go ahead and try this one now. All right, so this one is plus or minus 4i square root of 6. So you should have subtracted 96 from both sides, and so you would have gotten x squared equals negative 96. And when you do the square root of both sides, that is when you get the plus or minus. And then you think, oh, well, negative 96 will break into negative 1 times 96, and the square root of negative 1 is I, so that's how we get the I. And then 96 can be broken down further. 96 is a multiple of 3, so that becomes 3 times 32, and then 32 breaks down into 4 squared and 2. So 96 ends up being 3 times 4 squared times 2, which means the square root of 4 squared is 4, and then leaving you 3 times 2 on the inside, which is 6. Okay, let's go ahead and try this one. So this was a multiple step problem. The first thing you had to do was add 27 to both sides to get rid of the minus 27. So you would have had negative 3x squared equals 27. Then you would have divided both sides by -3. So you would have gotten x squared equals -9. And then you would have square rooted both sides, which would have given you the plus or minus symbol. And then the square root of -9, well, the square root of -1 is I, and the square root of 9 is 3. So that's how you get plus or minus 3i.